Hello students, by this video let us study about the affinity of chlorine for hydrogen, which comes under the chemical properties of chlorine of p-block elements too. So chlorine is having a very good affinity for hydrogen. Chlorine can react with all the compounds which contain hydrogen. So few examples let us study over here. Turpentine, water, ammonia, hydrogen sulfide. So these compounds chlorine can react. Yes, why chlorine can react with these compounds? Because there are hydrogen containing compounds, right? So chlorine is having high affinity for this hydrogen. Affinity means attraction towards the hydrogen. So let us study one by one. So first let us study about turpentine. So well we know this term turpentine. You might be coming across the word turpentine. So generally the people who do paint works, so after painting they wash their brushes with turpentine. So turpentine is a solvent. So it is generally extracted from pine trees. Okay. So this turpentine, it is a hydrocarbon, organic compound. It is a resin. Yes, it is acting as a solvent. It can solubilize or dissolve the paints. So for that reason only the paint workers, they generally wash their paint brushes in this turpentine and make it clean. Okay. So it is having a different smell, and irritating smell it is. Okay. An addiction smell it is. Okay. So turpentine. So that is the hydrocarbon turpentine. Okay. So this turpentine, so let us write the reaction here. So turpentine C10H16, so that's the formula for turpentine, react with chlorine to give hydrogen and chlorine combined together to form HCl. Chlorine is having high affinity for hydrogen, so you get HCl carbon. Yes. Now let us balance the reaction. So turpentine, when it reacts with chlorine and hydrogen combine to form HCl and remainder 10 carbon. So here 10 carbon, here only 1 carbon. So I just balance it by putting here 10. Okay. Now here 16 hydrogen is there, whereas here only hydrogen, so I put here 16. Now here it is 16 chloride, whereas here only 2 chloride. So to balance I put it here 8. So this is the reaction of chlorine with turpentine. Okay. Next we will see with water. So chlorine, it can combine with water. So chlorine gas, it can combine with water. When it combines with water, this combination of chlorine with water is take place in the presence of sunlight. Yes. So in the presence of sunlight, what happens when chlorine is mixed with water? The chlorine color, that is the greenish yellow color, that is lost, and the smell of the chlorine is also lost. Okay, the pungent irritating smell is also lost. Then why it is lost in the sense all the hydrogen combine with chlorine and form HCl. Okay, so along with HCl, dioxygen is also obtained. So this is the reaction taking place when chlorine react with water. Chlorine is having high affinity for hydrogen, so chlorine and hydrogen combine to form HCl in the presence of sunlight. Yes. So when it is exposed to sunlight, the irritating smell, yes, and the color, a greenish yellow color, that is lost, and as a result hydrochloric acid is being formed in the water along with the dioxygen. Okay. Now let us balance here. Here it is 2 hydrogen, yes, so I just put it over here 2, yes. Now oxygen, here only 1 oxygen, yes, so I just put it over here 2 oxygen. Yes, so when I put here 2, it becomes 4. So what I will do, I'll change this, it becomes 4 hydrogen. Yes, now here it is balancing of chlorine, the reaction of chlorine with water. Now let us see how chlorine reacts with ammonia. So chlorine react with ammonia by two methods. That is, excess of ammonia react with chlorine, and another one, excess of chlorine react with ammonia. So likewise, two steps are involved here. Okay. So in the first step, excess of ammonia. So here, in this reaction, we are taking 3 moles of chlorine. Okay, 3Cl2 we are taking. Even here also, excess chlorine, in this case also we take 3Cl2. So in both the cases we are taking only 3Cl2. Beyond that we are not taking. Now here excess of ammonia is used reacting with this chlorine. So for that excess we just write 2 ammonia. Whereas here excess chlorine is used, so we decrease ammonia and we write this as NH3. Okay, now we'll see what is the product obtained here. So when ammonia combined with chlorine, we get 2 products. So one is your nitrogen gas, dinitrogen gas, and another one is HCl. Okay, likewise here also ammonia combined with chlorine, and here also you get the 2 products. One product is NCl3, nitrogen trichloride, S and HCl. So these are the products you get. Okay, now let us balance here. Here it is 6 chlorine, there is only 1 chlorine. So for balancing, I just put here 6. There is 6 chlorines, that is balanced. Now 6 hydrogen is also balanced, and 2 nitrogen, here also 2 nitrogen, that is balanced. Now in this case, let us balance here. Here it is 6 chlorine, whereas here 4 chlorine, and here 1 nitrogen, here also 1 nitrogen. Here it is 3 hydrogen it is, whereas here only 1 hydrogen. So to balance, I put it here 3. Okay, now 3 chlorine plus 3 chlorine, 6 chlorine, so like it is balanced. And 1 nitrogen, that is balanced. Okay, now this 6 chlorine again react with ammonia. Again react with ammonia to give, yes, likewise here also 3 HCl again react with ammonia to give ammonium chloride NH4Cl. Also 3 HCl and ammonia combined to form NH4Cl, that is ammonium chloride. Okay. Now it is 6 HCl combined with, now look into this. So here one hydrogen, so 1 hydrogen, 4 hydrogen, 1 chlorine, 1 chlorine, 1 nitrogen, 1 nitrogen. So because we write it here 6, we put 6 here. 6 HCl combined with 6 ammonia to give 6 moles of ammonium chloride. So likewise 3 HCl combined with the 3 moles of ammonia to give 3 moles of NH4Cl. So this is the reaction taking place. Okay. Now let us write the net reaction. 2 reactions are there. In this reaction 2 steps are involved. Yes. So let us write the net reaction. So while writing the net reaction, what happens in both the reaction? What is common? We just cancel off. Okay. So here 6 HCl, here also 6 HCl. So let us cancel it. Fine. So find what is left over. So that we will write. So 2 ammonia plus 6 ammonia. So how much? 8 ammonia. Plus then 3Cl2 gives nitrogen plus 6 NH4Cl. Fine. So that is the net reaction of ammonia reacting with chlorine. Now we will see the net reaction for the reaction of ammonia with the excess of chlorine. Okay. So here also, here 3 HCl, here also 3 HCl, cancel. Okay. So here 3 ammonia plus 1 ammonia, 4 ammonia, 4 ammonia plus 3 chlorine, so 3Cl2 gives NCl3, that is nitrogen chloride plus 3 ammonium chloride, 3 NH4. So this is the reaction taking place when ammonia combined with chlorine. Okay, so fine. So that's all the reaction with that of ammonia. Fine. Now the next reaction is the hydrogen sulfide. Now we'll see how the chlorine react with hydrogen sulfide. So chlorine oxidizes this hydrogen sulfide to sulfur. Okay. So we'll just write the reaction. Hydrogen sulfide react with chlorine gas to form sulfur plus HCl. Yes, so that means chlorine is acting as an it oxidizes hydrogen sulfide to sulfur and HCl. Likewise, even the potassium bromide and potassium iodide, that is also oxidized by chlorine to give. In the case of potassium bromide, you get bromine, and in the case of potassium iodide, you get iodine. Plus, now what else will, after once the bromine is removed, what else will be left? Potassium and chlorine combine to form KCl. So likewise here, when iodine is removed, potassium and chlorine combine to form KCl. So reaction is very simple, provided you know the formula. So now let us balance here. So here one sulfur, so that is balance. Here 2 hydrogen, 2 chlorine. So to balance I put here 2. Fine. Now look into this one. 1 bromine, 1 bromine. Here 2 chlorine. Yes. So I put here 2. So when I put here 2, it becomes 2 potassium. Whereas here only 1 potassium. So I put here 2. Now it is 2 bromine. Here only 1 bromine. To balance I put here 2. Okay. Now likewise here also 2 chlorine. So here only 1 chlorine. So I put here 2. Yes. Now it is 2 potassium. Here 1 potassium. So I put here 2. Now that is also balanced. Now here it is 2 iodine. Here only 1 iodine. Put here 2. So the reaction is balanced. Very simple. Very simple. Provided you just understand the formula. So once you understand the formula, reaction can be written easily and balancing also can be done easily. Okay. Little bit of care and attention should be required. So whenever you listen to this lecture or the video, you take a paper and a pencil, and as you listen, please note down there, so that will become a practice for you and you will learn it thoroughly. Okay. So both together, looking into the book and watching the video, sometimes it will confuse you. So either you watch the video and look into the book, or look into the book and then watch the video. Fine. So after watching the video, if you look into the book, the concept will be very clear and you will know how the reaction took place. Yes. Fine. So it is easy for you to understand. So what I recommend is that watch the video properly, take down the points, understand all the reactions, the chemistry behind all these reactions. You just understand how the formulas are written, how the balancing takes place, all that you try to understand, and then you look into the book and then try to understand it completely. Fine. So hope you understood the affinity of hydrogen towards the chlorine. Thank you so much.